are written with a radicand, is what it's called. Radicand. Can you see that? Should I use a darker color? I'll use pink. An expression with a radical symbol is called a radical expression, because it has a radical symbol in it. The number or expression inside the radical sign is the radicand. You don't necessarily have to remember that number, but you might see it somewhere, and you kind of got to say, oh yeah, I remember hearing that word before. So this altogether is called a radical. The number inside is the radicand. This bothers me. The light is just not where it's supposed to be. That doesn't help, does it? A little bit better. Okay, the radical sign indicates the non-negative. We're going to be working with the non-negative solution because we're talking about side lengths and so on in a triangle. So we would never have a negative square root for this. Got it? So the square root of 25 is 5 because 5 squared equals 25. Correct? You should know all that. Square root of 25 is 5 because 5 squared equals 25. All right, now you got a calculator? Or one next to you, somebody, anybody need a calculator? Because we're going to be doing a little bit with calculator as well. You got to know how to find the square root, not on your phone. So as long as you know how to do it on a regular calculator, you can use your phone today. But of course, on the test, you're going to need to know how to do it on a regular calculator. So find the square root of 52. So I need to find the square root of 52. I need to round my answer to the nearest tenth. To the nearest tenth. So on some calculators, you got to push the square root button first. This is so annoying. It's not working very good. Just can't see it. You probably can't see this at all. So you got to put the square root button first, which is right here above the squared button. Maybe, do y'all know how to do it? Find the square root of 52, hopefully. Okay. And I get to the nearest tenth is approximately 7.21111. So you drop all those off, and you just have approximately 7.2. That's your answer when you have to go to the nearest tenth. So then if you square that, 7.2 squared on the calculator is approximately 51.84, which would round up to 52. Okay? But since it's not, since we're dropping off all those decimal places, it's not going to be exact. All right. Use the Pythagorean theorem to find the length of the hypotenuse of the triangle to the nearest tenth. You can see that these legs, remember these are the legs in a right triangle. That's terminology you're going to need to know for this chapter. And this is called the what? What's it called in a right triangle? Hypotenuse. Okay, the legs are the A and the B. So I got square root of 2 squared plus the square root of 3 squared equals C squared. What's the opposite of square root? Squaring, right? So they undo each other. So what's the square root of 2 times the square root of 2? Say it loud. These two operations cancel each out, square root and squaring. Remember? It's 2. If you did it on your calculator, square root of 2 times square root of 2, you would just get 2. Okay? So this is 2 plus 3 equals C squared. They're opposite operations, so they cancel each other out. All right, and then 5 equals C squared. Do I want C squared? No. It says here I have to go to the nearest tenth, so I got to take the square root of both sides. and C would be approximately 2.2. So that's how long the hypotenuse is, approximately 2.2. All right. So this is just, we're going to just kind of talk about this property here. The squaring of radicals property. If you have the square root of a number and you're squaring it, it simply means this, the square root of A times the square root of A, which is just going to be A, that number. That's the property. That's all it's telling you. So for example, if I have the square root of 4 squared, what's the square root of 4? So this means this, right? That means that. And what's the square root of 4? 2 times 2, which equals 4. I just kind of proved that right there to you. It just equals what's underneath, okay? All right. Yeah, I'm really bummed about the brightness of it. I don't know why it's so. Does that help? Okay? I know. I don't know why. It's weird. Okay. Product property of radicals. So what does product mean in math? Multiply, right? So if I'm going to multiply two radicals together, different numbers, A and B, different numbers. What this says is that I can put them together underneath the same radical sign. This and this is legal. They're the same value. So I can interchange that. I can do this and go to here, or I can take this and go to here. So as an example, the square root of 2 times the square root of 3 is the same as the square root of 2 times 3. Same thing, which is equal to the square root of 6. These two properties are important in helping us study or simplify expressions with radicals in a variety of ways. So that's what we're going to kind of do on the back side of this. So flip it over. Okay. All right. Using the properties of radicals to simplify the radical expressions below. Notice there's no mention of leaving your answer in decimals, so we're not going to do that. We're just going to leave it in radical form. So these are split up. What did that property say that I could do that maybe would help me simplify? Put them together. So I'm going to put them together according to that one property on the front. And then I can just write it like that. Square root of 21 is as far as I can go. 21 does not have any perfect square factors here. Nothing at all. Okay? Here's 21. It's 7 and 3. That doesn't work. So this one here, again, they're split up, so it doesn't do me any good that way, so I'm going to put them together as 5 times 6, which is the square root of 30. Can't go any further. 30 doesn't have any factors that are perfect squares. All right, here, look at how this is written. This is the same thing as 5 times the square root of 3 times the square root of 2. Just because the dot's not there doesn't mean it's not multiply. It's all multiply. I'm not going to do anything with that. All I can do for this is put those together, and that's as far as I can go. That's it. I can't do anything else. I'm not supposed to leave it in decimal form, so I leave it like that. Okay, in the back. Shh, guys. All right, so this is the same. Just because there's no dots here doesn't mean it's not all multiply. It's all multiply. Therefore, I can rearrange it. It doesn't have to stay in that order. If it helps me, I'm going to rearrange. So I'm going to put the numbers that aren't radicals next to each other and the numbers that are radicals next to each other. And that is a little clearer now. What's 7 times 2?
14.
What's the square root of 5 times the square root of 5? Just plain old what?
25.
No, 5, right? These two are just 5. So then I do 14 times 5, and that's my final answer. Okay? And that would be 70. So So there's different ways you got to look at it sometimes. You with me, Alexis? What did we say right here? The square root of 5 times the square root of 5, right? If you can't, let's write it up here. Square root of 5 times the square root of 5, you could also write it as the square root of 25, which is actually equal to what number? 5. I just skipped that step and said I know that those two together is equal just to 5. Okay? All right, simplify the radical expressions. Simplify means no decimals. So I've got to look for perfect squares, and we did this before. Maybe listing your perfect squares here is helpful. I don't know. It might be. Why are they perfect squares? We talked about this before. A couple months ago. Because their square root is a what? Not a decimal. Not a decimal. All of these are perfect squares. Their roots, like the root of 16 is 4 and 4. The root of 25 is 5 and 5. Okay? So, what's the square root of 100? Does it have a perfect square factor? 10, right? I could write it like this, the square root of 10 times the square root of 10. Or I could just write it as 10. I know that. Now, 12, I can't take the square root without a decimal, so I need to think of a factor of 12 that's a perfect square. What's a factor of 12 that's a perfect square? 4. 4 is a factor of 12 that's a perfect square. So I'm going to write it like this, the square root of 4 times the square root of 3. That's the same value. How does that help me? I can take the square root of 4. What's the square root of 4? Right. I cannot take the square root of 3 without a decimal, so that's as far as I can go. That's simplified. 3 doesn't have any factors that are perfect squares. Okay, 75. If I take the square root of that, it's a decimal? Can't do that. Is there any factors that are perfect squares of 75? 25, right? That's the biggest one, 25. So I'm going to write it as the square root of 25 times the square root of what? 25 times 3 is 75. So that's the same value. Now I can take the square root of 25 because it's not a decimal. It's just plain old 5 times the square root of 3, and that's as far as I can go. Does 200 have any factors that are perfect squares? Look at your list down here. Any factors that are perfect squares? Which one? 100. So, I'm going to write 200 as the square root of 100 times the square root of 2. It's the same value. And what's the square root of 100? 10. Now, here's a common mistake. Don't write this down. I'm just going to show you. For example, here, in this problem, they get this far, and then people write their answer like that. What's wrong with that? You're saying to square root twice. You already took the square root, so you don't write it anymore. I see lots of people do that. Okay, so that should not be there. Don't write that down. That's just a common mistake that I see. All right, when you simplify, always look for the biggest perfect square factor, which is what the number can be divided by. The biggest perfect square factor when you simplify. And you have a list of those right here, and it's the highlighted numbers. That's what you're going to be working with here. Okay? All right. So this is kind of like part of what you're going to be doing in your homework, this top part. Here's the second part. Simplifying is different for different types of expressions. Sometimes you have to sit and look at it a second and say, what can I do here to help me? Look at these two numbers. Wait a minute, this is pretty easy. What's special about these two numbers? They're both perfect squares. Courtney, put your phone on. They're both perfect squares. What's the square root of 9? And if you don't know, can you go here? Square root of 9 is 3. Okay? Oh, so this is just 3. What's the square root of 16? Oh, so that's the same as 3 times 4, which is 12. That one was easy. That gave me perfect squares to work with. Here, you could look at it and you could split it up like this, right? We could say, oh, this is the same as this and go that way. Or I could multiply them together and say that's 144. 9 times 16 is 144. Either way, you could look at it. This would be 3 times 4. Or what's the square root of 144? 12. It's a perfect square. You can get that off of my list here. So the answer here is 12. You can look at it either way. Doesn't matter. Oh, now we have a problem. What's this? Addition. You cannot put them together when there's an addition. Don't do it, okay? All you do is you just work as this thing as if it's an adding all the way down. So what's the square root of 9? 3. Then you bring the plus sign down. You cannot combine them until after you've taken care of those roots. What's the square root of 16? And then you add them together and your answer is 7. See the difference? It's very different. Okay, here, I want you to put a note to yourself. You cannot split. You can't split. You must add first. Because it's an addition, you cannot split it up. It's mathematically illegal. So add them together first. So it becomes the square root of what? 25. 9 plus 16, which is 25. And then the value of that is 5. So you can see that these involved multiplication, and they were both 12. These involved addition, and they got different answers. Okay? So you have to kind of watch that. All right, almost done. Be careful, you can't split up addition. And it's a common mistake. I see that. I know we already wrote that down, but all right. So you're going to see problems like this. This is the second type of problem you're going to see. Almost done. Simplify. Oh. What does this mean? I'm going to write this down. A number next to a radical. That means number next to a radical means to multiply. A number next to a radical means multiplication. So here I have this whole thing squared, which means 3 times the square root of 5 times 3 times the square root of 5. That's what that means. Now remember, I told you before that this, just because there isn't a dot here, doesn't mean it's not multiply. It is multiply. And you can rearrange multiply, right? That's like we did that before. So I'm going to rearrange it and put the numbers that don't have radicals next to each other and the numbers that do, just so it's easier to see. What's 3 times 3? I can do this multiplication. Times the square root of 5 times the square root of 5 is what? 25. It's the square root of 25, which is 5, just 5. So we can write it like that, or we can just know that just from this property on the front, any number, any square root times itself just equals that number. Or you can look at it as the square root of 25, and then it's 45. All right, you do this one, same way. Same thing, you try it. Do you have to write it all out? No. If you're seeing this without writing it all out, this that rearranging and stuff, you don't have to. Yes? You don't even need a calculator because you can see that 11 times 11 is 121 and the square root of that is 11. Okay. This is different. I'm going to give it a different color because it's different. Is there any squaring going on here? No. But I still have to simplify. There's nothing I can do with that 2, so that's going to stay out front. Nothing I can do with that 2 for now. But 20 has a factor that is a perfect square. 20 has a factor that's a perfect square. What number is it?
10.
That's not a perfect square. This list right here. Your highlighted numbers. It's 4. So I'm going to write this as the square root of 4 times the square root of 5. It's the same value. Square root of 4 times square root of 5 is the same value as square root of 20. That helps me because I can do what? Take the square root of 4, which is what? 2. This I can't do without a decimal, so that has to stay that way. So the answer, the simplified answer, is going to be 2 times 2, which is 4, times the square root of 5. I cannot go any further there. That's as far as I can go. No decimals in my answer. All right, let's look at this. This one's going to be slightly different. This is also all multiply. So the first thing I'm going to do is just rearrange it, because I can. And then I could do 5 times 7, which is 35. Kind of stuck here. I can't, there's nothing on this list that are factors of these, but I could do what? I could put them together. What's 3 times 6? Oh. Does that help me? Does 18 have a factor that's a perfect square? 9. Oh, isn't that nifty? Now I could take it further. I could write it as 35 times the square root of 9 times the square root of 2. Because that's the same value of 18. And then the last thing I can do is 35 times, what's the square root of 9? 3 times the square root of 2. And then I multiply 35 and 3. So it's going to come over here and be 105 times the square root of 2. Almost done. All of this work was leading up to these two problems. Find the missing side length. Oh, you should look at it and say, it's a right triangle. What do I use to find the missing side length of a right triangle? Yes, Pythagorean theorem. Yes, very good. I need to use the Pythagorean theorem. Simplified radical form, I have to use the Pythagorean theorem. Okay? So I'm going to write down, not too big, don't write too big. Which one's always C? This is C. These could be A or B. It doesn't matter. I'm going to make this A and this B. Just so we're all the same. Okay, I don't know A. I know that B is the square root of 5, and I have to square that. And C is the square root of 13, and I have to square that. It's not as bad as it looks. A squared plus, wait a minute, what's the square root of 5 squared? Just plain old 5. It's just 5. And this is just 13. Oh, but this gets better in the back row. You need to pay attention. It's not as easy as you may think. Okay, now I got to subtract 5. And A squared equals 8. But I am not done. I don't want A squared. I want A. So what do I do? Square root. You may think you're done, but you're not. Because 8 has a perfect square factor. Which one is it? 4. So I need to take this and write it like this. That's the same value, because I need to put it in the most simplified form. What's the square root of 4? 2. Now I'm done.
not do the last one.
No, we're going to do the last one. I know. All right, find the area of the rectangle. How do you find area of a rectangle? Base times height, or length times width, correct? So we really just have to multiply these two together and then simplify. So area equals base times height. Area equals 3 times the square root of 10 times 2 times the square root of 5. This is one of those rearrange, because I can. 3 times 2 times the square root of 10 times the square root of 5. 3 times 2 is 6 times the square root of 50. I'm going to see if that helps me, because I can't do anything with that. Oh, does 50 have a perfect square factor? 25. 50 can be divided by 25. And that'll help me simplify. So, I would write it like this. Same value as the square root of 50. What's the square root of 25? So, I'm going to have 5 times 6, which is 30. 5 times 6, which is 30, times the square root of 2. That's as far as I can go. Do you remember simplifying square roots before?